We're asked whether this ordered triple 1, 3, -6 satisfies this system of equations. If the answer is yes, then we should be able to plug in a 1 for x, a 3 for y, and a -6 for z into all three of those equations and get a equivalent expression. If not, then we have a problem. So let's give it a try. So for the first equation, I'm going to plug in a 1 for x, a 3 for y, and a -6 for z. And I want to see if that will give me 31 on both sides. So let's go ahead and multiply 2 times 3, and -4 times -6 will give me a positive 24. And then we add 1 plus 6 is 7, plus another 24 is 31. So this one looks great. We don't want to jump into saying that this ordered triple is a solution to this system of equations yet, because we need to check all three. So checking the next one, let's plug in a 1 for x, a 3 for y, and a -6 for z, and we'll see if that answers negative, or if that equals -1. We get 2 plus 3 plus a -6. So 2 plus 3 is 5, plus a -6 is, sure enough, -1. So things are looking great so far. Might be tempting to say, okay, yes, it is a solution, but we need to make sure it satisfies all three of those equations. So we're going to plug in a 1 for x, a 3 for y, and a -6 for z. Be careful with your signs there and see if it equals 7. So 4 times 1 is 4, 3 times 3 is 9, minus and a minus is going to make a plus, equals 7. So we get 4 plus 9 plus 6. Well, that is not 7, that's 19. We get 19 equals 7. Not a true statement, right? So it's a good thing we checked all three, because it failed the third equation. It did not yield a true statement. So because that was the case, even though it was true for the first two, because it wasn't true for the third, we have to say that our answer is no. It does not satisfy that system of equations, and it is not an answer to that 3 by 3 system.